start. Yeah, right.
Yeah, I started the meeting, so I think recording started. Yeah. Hey, hello everyone. So today's topic is a lot of application developers used to ask me, what does a system programmer do, right? And even in my career, at least for the first 10, 12 years, I've worked as mainframe developer in different organizations, different customer locations, from service companies. I've never understood what a system programmer does, right? Actually, that the day when I started understanding it was when I was in an on-site location where the mainframe was there in the basement, and then we were working on the third floor, and then the system programmers, operators used to sit on the basement and the first floor, right? That's actually when I really met system programmers, right? So it was a black box till that point in time, and then and I'm sure that's how it is for many of you. So the idea here was, and thanks to Saurabh and Prabal, who have spent good amount of time preparing this presentation, and both of them are senior mainframe system programmers. So they will give a quick overview of what a system programming means, right? And in the mainframe world, right? So that's the idea. Again, this is a vast topic, right? This is somebody's career, and it's not one career. There is a zOS system programming, there is CSE system programming, there's DB2 system programming, there's so much system programming, right? So it's a huge thing, right? Multiple careers. So we are not going to cover everything today. The idea here is to give you an peek into their life. And then based on questions, based on your interest, people typing out things saying, hey, I want to learn this in system programming and stuff like that. Like, again, this is not meant to make you a system programmer. This is meant to make you whatever job that you are doing in mainframe. In addition to that, this will help you um, um, to learn what system programmers do on the shop, right? So yeah, if there are other areas of interest in system programming that you are interested in, want a little more on WLM. I want to know a little more on um, schedulers, right? I don't know, right? So type it in the chat, and then we can figure out either Saurabh, Prabal themselves can take the sessions on those, or we can find other experts who will do it, right? Again, this is a community event, right? I'm not trying to put my own thoughts into this. So you all have to talk and say, this is what we want, this is what we don't want, for us to understand it. And then my job is to go find experts on that area, come back and do the sessions, right? I really don't want only my ideas to do it. Right? Okay. So let me stop speaking. It's almost 10 minutes, so I should do that and then hand it over to Saurabh. Saurabh, Prabal, over to you.
Thank you, Senthil. Thank you for all the efforts you're doing for the mainframe community. And good morning, all, and thank you everyone for joining today. As Senthil mentioned, along with me, Prabal is here today, and both of us work as a mainframe system programmers. And we would like to share our experience with you on our job roles and responsibilities. The main aim or motive of this meeting is to understand what really happens behind the scenes or behind the screens on the ZOS system, beyond what developers or application programmers normally see. We will look at how mainframe delivers. We all know that mainframe developer delivers 99.999% availability, but we will look at more on this. What a system programmer actually does to keep the system stable, how incidents are handled in production, and why system level thinking matters for performance, for security, and for the outages. Everything. We will discuss here everything. So, if I say here, we are not here as an expert giving a lecture. We are here as a practicing system programmer, sharing what a normal and sometimes not so normal days looks in the life of ZOS system programmer. I said not so normal because there can be a days where we have unplanned changes, where we have unplanned incidents coming to us. P1, P2, P3, any day, anytime, at night, at morning, at early morning. It can come at any day in the life of the system programmer. So, since many of us here are developers, application programmers, many developers see outcomes. Many developers see performances, outages, and security, but they don't always see what goes on what goes on behind the scenes. They don't always see what incident occur, what caused them, how they are permanently resolved. When everything works, so we would like to discuss all those things. How incident is coming, what is causing them, and how we as a system programmer or any system programmer, be it cakes TB2, we will explain all the roles in the latest slide. When everything for this. Okay, so we all knows that when everything works, you as a developer see speed and stability. When something fails, we all see outages. What developers don't see is the system level work happening behind the scenes to prevent. So I would like Prabal, do you want to add anything about today's session?
Yes, Saurabh. Thank you. Thank you so much, Senthil, for having this. And good morning, everybody. This is Prabal Bharadwaj here. Along with Saurabh, I also come with around a decade-long experience in the system programming world. Thank you, Saurabh. As you rightly mentioned, it's a high-level introduction to the GIS system programming, and we'll try to cover mostly how a day in our lives look like. This session is not about teaching the commands. It's not about showing green screens. It's about explaining how system programmers think, how we work, how we assess risks, and why we sometimes say yes and sometimes say no to the production changes in the system. Let us start with one simple line, which comes to my mind for system programming is the best day for a GUI system programmer is the day when nothing extraordinary happens. And by extraordinary, I mean there are no outages, no escalations, and no emergency calls. I know many of us here will agree that's also our favorite kind of a day, right? But the interesting part is this system silence keeps banks running, salaries credited, flights flying, and governments functioning smoothly. We both would have like to have this Saturday morning of yours being productive. Saurabh will take along from here on the slides, and I'll also pitch in between. Thank you, Saurabh.
Thank you, Prabal. Okay, so we have made slides, and we will explain you. We will show. Means Prabal is sharing the screen, and we have the first slide there. So through the slides, we will cover what our day looks like in reality. What are the first thing we means as a system programmer checking mornings, planned work, change windows, on-call incidents. Along the way, we will explain IPL, most important, SMP, very, very important, monitoring and the modernization that is going on the mainframe side. It's not going. It's like we are using the modernization. We are using the new features of the mainframe. It was there, but now we are using it. We want mainframe to work. We want mainframe to work as similar as the alag distributed platforms we have. We want them to interact. We want them to work together. Okay, but before we go there, let's answer two questions. We always hear since the day. I mean, I always have heard these questions from the day one. Um, uh, since that means I've started my journey in the mainframe world. Number one, since I started as a system programmer, so number one question comes to me all the time. At in my earlier days, who is mainframe system programmer? And second question come to me all the time, not from the mainframe people, but from the other people also. So if mainframe are so old, why they're still running the world? Anyone would like to answer the first question? Anything you want to answer? Who is mainframe system programmer? Any basic language definition or layman terms? Anything?
Hi, Navneet here. Can I go?
Yeah, Navneet. Good morning,
So,
Navneet.
good morning, Saurabh and Prabal. Thanks for this session. So, to answer your question in layman terms, what I understood recently is if mainframe is a server, then
Yeah,
system programmer is the IT administrator of that server.
very right. Very nice, Navneet. Right. It's like we are system programmers, radio system programmer, the custodian of the mainframe systems or mainframe operating system, we can say. Very right. Anyone else like to share anything? From this session, we want to learn. We want to learn our knowledge. We want to see what other people on the mainframe side are doing. I mean, mainframe is not about one role, one job. It's about many roles, many responsibilities.
Hi, this is Mohan.
Yeah, Mohan.
Uh,
Good
as
morning.
now, Hi, good morning. Thanks for the session. As
Yeah.
Navneet pointed out, as a as a day-to-day duty of the system programmer. System programmer will be taking care of new installations, upgrades, as well as
Right.
managing the security.
Very right.
Also monitoring the performance of the system, so it is not degraded due to the running applications.
Right. Right. Very right, Mohan. Right. So, I mean, we have this slide specifically for the system programmer. We have made that slide, but we would like to explain you in a very high level. We will cover in details in the coming slide also, who is mainframe system programmer. Mohan and Navneet said very rightly. So a system programmer owns the operating system, right? So if, I mean, applications runs on the zOS system. So if an application fails, we know that. Why I'm taking about application example, because many of us are the here are application developers, so you can correlate at that point. So whenever the application fails, we all know business is impacted. But if the zOS fails, if the system fails, everything is impacted. That's what the job of the system programmer is, to make sure the system failures extremely rare, right? We work on that thinking, on that principles, that we don't want any failures anytime. So let's explain this in a very layman term. I will use very layman terms so that we can explain this. So you can think of a system programmer like a air traffic controller. Okay, so who sits in the command control room? We all knows that a group of persons are sitting in the control room, a watchtower, and they are directing the flights, directing the pilots with respect to their knowledge, or with respect to the data coming to them, right? So system programmers are like the air traffic controller, okay, who sits in the command control room. So passengers, pilots never see the control room, right? But one wrong decision from the air traffic controller there affects everyone, right? So one wrong decision from the system programmer with respect to the system planning, with respect to the resources, with respect to the capacity, with respect to the security, with respect to the maintenance, affects everyone. Everyone means all. Okay. So I said two questions. Number one was system programmer. We understand it in very layman term, right? Now, second question comes, if mainframe are so old, why they are still running the world? I just twisted this question. We kept hearing this question, why we are using the mainframe, why the industry is running on the mainframe. So I don't want to hear that question. So I just twisted it. If mainframes are so old, why they're still running the world? Right, we have the information from the slide, but anyone wants to pitch in anything there? We all knows the answer, right? But still we are explaining this question again and again to everyone. Anyone wants to pitch in there?
Zero downtime, high
Very right.
availability,
Very right. Yeah.
performance.
Yeah, very right. Right. So thank you. So if I mean, if I hear the word mainframe, right, I will talk about myself because I love mainframe from the day I started journey on the mainframe. I'm going to work on the mainframes, I will say like that only. Okay, so when I hear the word mainframe, the first picture or word I think of mainframe that comes automatically, right? It's a natural human thing. So that what picture comes to my mind? What thoughts come to my mind? It says to me, old, what very solid, very solid, right? Mainframe survived till now plus 50 years, not because they are trendy, something like that, or they have some UI, fancy UI. No, they were built for a very specific kind of problems. If you see these boxes in the slide, right, I have written mission critical systems. So mission mainframes were built for the mission critical systems. Now, what are critical systems? Critical systems where downtime cannot be an option. Just now, someone said zero downtime. Very right. For critical systems, downtime cannot be an option. Those systems are used by banking, airlines, government sectors. 99.999% availability. It's an expectation from the mainframes forever and from the day one. Right? If we go to box 2, purpose-built architecture. So mainframe architecture is something like that. We all have seen that also. You can run the same legacy workload year after year without compatibility issue, right? In 90-70 applications will run today also on the modern zOS systems without issue. So this is the main principle of the, you can say, of the mainframe, backward compatibility. It's a core IBM design principle. Third is reliability guarantee. I feel this is very important. This is most important. Mainframes survive decades because they solve hard problems reliably again and again. And if we go deep in these words, right, hard problems again and again, reliably with respect to our mainframe. So by hard problems, we mean problems where millions of people are using the system at the same time, 9 a.m. in the morning, Monday morning, right? We all log in at same time. So what do you mean by reliably? Means it worked not just one, but every single day, including the peak days, upgrade days, bad days. And again means this didn't happen for 1 year or two. It has been happening for the decades. Mainframe is there from the past 50 plus years, right? And means anyone can run a marathon race, right? Means now we can run a marathon race, but we can run only for once in a week or once in a month. I feel once in a week is too much. Once in a month, I feel that we can run it, right? But mainframe is doing it from the past 50 plus years without any downtime. So because these systems were designed in 1960s, something like that, these systems were designed to stay up all the time while we have the software changes, while the business grow. Very, very simple example. If we say in today's world, with respect to our today's world, social media can go down for an hour, right? It can go down for, we have seen it also sometimes, WhatsApp, Instagram, any other social media platform is going for a downtime for 1 hour. It's annoying to us, right? We feel annoying for 5-10 minutes, and then it's normal for us. But when the core banking goes down for 5 minutes, it's a national issue. So like I said, mainframe matters on the Monday morning at 9 a.m. when millions of users like we all are users of the mainframes, we all log in at once with different responsibilities, with different roles. Where the system programmer log into mainframe with respect to different responsibility, and you as a developer, application programmer, or some other security administrator log in with these different responsibilities. But we log in at same time, and mainframe treat us all in the same speed. Now, if you are able to see the third slide, again, we all know the answer, but we will explain it one more time. Why mainframe survived? We have covered a little on this also, but we will like to share something on that also. So, but in today's world, what is happening is like we are comparing mainframe to the cloud or to the distributed system, but it's totally a wrong comparison, right? You can't compare cargo ships to the sports car we have, high speed sports car, right? Which can go in 100 kilometer per hour in some seconds, right? So both move, right? Cargo ships also move and sports car also move, but both are built for completely different purposes, right? Cargo ship is built for different purpose, sports car built for different purpose. You can't compare them. Similarly, mainframe and cloud can't be compared. If you see the pyramid type of structure, and in the five we have availability. As we discussed, this is the promise the mainframe has made, and it has never been broken. All people here who have joined the session can't complain this. No one can say no, this is wrong. Everyone knows this. But this availability is not enough. We need predictability also. Predictable means no surprises at the peak time. Peak time means month-end activity. So every month-end activity should look like any other day for the system and to us. Optimize throughput means business finishes all its work on time and every time. These systems have been designed to process very large volumes of work. Okay, it's not designed for one transition, two transition.
Saurabh, sorry, I'm going to interrupt. Okay, I think we should move a little forward with this, right? Because this is a group that knows most of this content.
Right.
I really don't want to lose the momentum that you have. And then people will get Saturday. People will have their own work. So
Correct. Correct, Senthil.
sorry.
Okay, so no worries, Senthil. Thank you. Team, I will move a little faster. Wherever you want, stop me, and we will explain in detail there. Okay, but I will say let's complete that slide. And okay, just go. Okay, backward compatibility. We all knows. We have explained this. Decays of workload. We all knows. Uh, some applications running on zOS today are older than all of us in this team meeting. So they were written years ago, enhanced many times, but they're still running without interruption. So we understand why mainframe survived. But here's the interesting part. Despite all these powers of the mainframe, we never see, or most people never see zOS at all. So next slide will cover this, where zOS lives. Okay, so zOS live deep inside the enterprise data centers. Okay, we all knows what are data centers. It runs on the IBM Z hardware. There is no graphical UI for that. End users never touches it directly. Okay, and okay, zOS plays exactly that role in the enterprise system. Means think of zOS like an engine room of a cruise ship. Okay, we never see, if we are the passengers on the cruise ship, we never see the engine room, right? But but we enjoy the journey, right? zOS exactly plays that role in the enterprise system. In the enterprise stack, application talks to middleware, we know that. Middleware talks to operating system, we know that. And the operating system talks to hardware. zOS sits right in middle of this ecosystem. Okay, so if you go to the next slide, if you never see zOS, what exactly it is doing all day? Okay, what is system actually designed for? These all also we know. So we have covered it, but in just one go, we will go. We all know that zOS was designed for a world where work never stops, data must never be lost. Yes, yesterday's application must still run tomorrow. Okay, we all know what are batch processing. We all know what is OLTP, that is high volume transactions, millions of online transactions per hour, continuous availability. We all know that from our heart. We know that continuous availability, what is there. We have batch running, we have online transactions running, and system is still running with the full speed and the resources. Backward compatibility, predictable resource control, the last one, right? So we know about this also. zOS control the resources through the WLM. Now, what is WLM? That is the core part of the mainframe. Okay, WLM stands for workload management, and we will understand WLM in detail in the coming slides. So maybe we will not spend much time here. But yes, in zOS, the resources are controlled with the help of the workload management. Okay. So far, as of now, we have covered what platform is designed to, how it runs non-stop, handle massive workloads. These guarantees like availability, performance, stability need someone to design, protect, and maintain them single every day, right? Let's go to the next slide. Okay. Oh, we are already here. Nice. Now, who is a zOS system programmer? We cover in very high level in the start. We all knows, I think, who is the zOS system programmer. As I mentioned, system programmer is the custodian of the system behavior. Someone mentioned, I think Mohan was there. He said to me, a system program install and customizes zOS operating system for an organization, right? Apart from this, a system programmer also installs the applications we have from many various vendors we have available in the market, the mainframe vendors, BMC, Precisely, IBM, of course, IBM, yeah, CA, Broadcom, Rocket. We take care of the installations and the maintenance. So installation and maintenance are the two different things, okay? And there is one more term with the name of fresh install. So if you say maintenance, maintenance means something is already running, but you are just patching it. Just understand with patching. You are applying the latest fix. Fresh installation means nothing is there on the system. You are installing it from the first time. And upgrade means you are on one version, but that one version is going to get end of support in coming months, in 6 months, 7 months, or in a year also. Now you have to, since that is very important application for the client, that is being used on day-to-day basis, so you have a responsibility to upgrade it, okay, from one version to the next version, which is the latest in the market, or it can be n minus 1. N minus 1 means the latest version we have minus 1, and we have a different reason why we go for n minus 1, because it gives us more stability, because that has been tested more, right? So this is the job of the system programmer. So we have stability, we know installation, we know performance. In mainframe is about making sure thousands of workloads run together without hurting or stopping each other, right? So this comes under the capacity planning. Security, we know security at the system level. We decide, or a security system programmer, a RACF administrator decide who can access the system, what they can do, and what is protected. The last box is most important for us, because a system programmer spend a lot of time thinking what could go wrong. Okay, let's suppose we are going for a change on Sunday. So before we proceed for the change, we have to analyze, okay, if this doesn't happen, what can be the outcomes? So we have to prepare for both, for successful change also, and for the fallback means unsuccessful, we are going back where we were. So we have to think on both perspective. IPL maintenance, we talk about maintenance, we talk about upgrades, we talk about configuration changes, everything, okay, all carries the risk. So now we understand who is the system programmer, right? Anyone have any questions, please? Okay, we are good. Next slide. So where exactly we fit in the mainframe world? Okay, now if you're seeing this slide, uh, today today's environment is something like that. We must know the mainframe environment as a whole. A mainframe is not one role, one team, or one skill. It's an ecosystem where multiple roles work together to keep the system alive. Okay, people, management, developers often says system issue. We have always heard this term. Okay, there is a system issue, there is a system issue, but which system, right? Is it hardware issue? Is it operating system level issue? Is it storage issue? Is it security, network? These all are different specialities. Okay, if you see the slide at the top, we have the mainframe environment. Okay, under this mainframe word splits into two major areas: applications and the system. Systems refers to the infrastructure. On the application side, we have application programmers and testers, right? These are the teams, or you are the teams which builds the business logic with the help of COBOL programs, JCL, assembler, right? Rex also, right? Your focus is always on the business functionality, okay, new features, okay, but you don't manage, or the application programmer don't manage the platform itself, right? On the other side, we have system programmer, the infrastructure owners. So we are the infrastructure owners. If you see, this is not one role, right? So we have different roles. It's a collection of deep specializations. Like one doctor can't see all those things, right? We have ENT specialists, and then we have heart specialists, we have lung specialists, right? Similarly for zOS also, we have different specialists. So one is hardware system programmers, that is managing CPC, HMC, firmware. Other is V, that is hardware system programmers, owning the operating systems, the very internal parts of the operating system, major subsystem, ZES, OMVS, SMF. Database administrator looks after the data, making sure the data is available all the time. Kicks, MQ system programmers, they are for the online transactions. Okay, security system programmers, protecting the system using the RACF. The RACF is internal, ACF2, or the top secret tools we have available in the market. Then we have storage system programmers. They are managing the DAS-D. We all know DAS-D, SMS, HSM. Network system programmers, TCP, VTAM. Automation scheduling, as Senthil also discussed in the start. Okay, we have schedulers available in the market for a specific role on the mainframe. They are using some tools like Control-M is there, OPC, TWS, CS7 to schedule the jobs. Okay, Then in the last, performance and capacity. So performance capacity means making sure they have to make sure that today's workload, right? Whatever workload we have on the mainframe now will still work tomorrow. And in the far right, if you see, we have operators. Operators are very, very important for the mainframe environment because they are like the eyes and ears of the system, right? They monitor console 24/7, watch bad jobs, raise alerts, looks for WTOs. When something goes wrong at 2 a.m., operators escalate. And system programmers, with respect to the systems, I will again say system programmer with respect to the system, with respect to DB2, with respect to ZOS, with respect to hardware, with respect to kicks, fix the root cause. Okay. So next slide. Okay, now we have seen mainframe ecosystem and role. Next slide is how a system programmer different from application programmer. We all know, but I will just take 1 or 2 minutes on this. Please understand, this comparison is not about who is better. It's about who is responsible for what. Okay. When an application fail, user complaints and 10% of the business, 10, 15, 20, depends on the applications, will get impact, right? When the system fails, complete breakdown, 100% loss. Nobody can log in and nobody can do his or her responsibilities. Application programmers, which are you, focus on features and logic. System programmers focus on stability, performance, availability. When something breaks at 2 a.m., the question is not what feature failed, right? Which application is not responding? It's, is the system still running, right? And this is where the collaboration between you and us becomes critical. Developers design applications, okay? System programmer protect the platform. And when we both collaborate early, production remains stable. And in critical systems, we understand what a critical system. Stability is success. If I say in this in a very, very funnier way, so when we both, right, when system programmer and developers talk early with respect to the future changes or what is the need of the business or what is the need of the developers, what is the ask of the developers, what system programmer can offer you. When we both talk early, right, production stays boring. I will again say production stays boring. And boring production is a good production for all the critical system. It's a smooth flow. Right. Anyone have any question here? Or we will move
Vivek.
to. Okay.
Yes, Vivek, please come up with your question.
Sorry, I was about to react and I raised the other button. Sorry about that.
No
That's
worries.
fine. That's fine, Vivek. No worries.
All right, we can move on.
Yeah, we can move. Okay, IBM Z hardware. Before we go deep into the ZOS software, ZOS applications, we have to talk about the machine itself. Okay, before anything runs on ZOS, okay, before the batch jobs, before ZOS can manage workloads, before applications can run, there has to be machine that never crashes, never loses data, never slows down, never becomes unstable under pressure. And this machine is IBM Z. Most systems, in today's world, everyone is doing that. Most systems are built to be fast, but IBM Z is built to be correct, to be consistent and always available. It is, and in IBM Z, we have multiple processors, multiple power supplies, multiple memory paths, multiple input output paths, dual support elements. If one component fails, another immediately takes over. And for that, most of these happens without, we don't need to reboot or we don't have the outage for that. That normally is mainframe understand from itself. Okay, this is not working. Let's switch to other. Business never stops for these machines. We don't want to go deep into the hardware internals here. We just want to give you a picture of the machine we are responsible for because system programming decisions are tightly coupled with the hardware. Let's go to the next slide. So these are the like JES, like SMF, RMF, right? These are the internals, core critical internals of the zOS. Similarly, CPC, LPAR, CPU, memories, input-output channels, DAS-D, these are the core criticals of the hardware. Okay. CPC is like a entire physical machine. Okay. It's like a, how can we relate? It's like a black box in the data center. Okay. Think of, or maybe you can think of CPC as the brain of the mainframe. Inside CPC, there are different type of processors we have. In zOS, not all work is treated the same. Some processors run core zOS workloads and some are optimized for Java or Linux. This separation helps actually control cost, performance, capacity. LPARs, we all know. This you can say LPAR as a separate machine. It has own zOS, own memory, own CPU. One LPAR in a same machine can run banking workloads and other might run the Linux or the test systems. So, okay. So consider LPARs are like the apartments, okay, in one building. We have a Prestige building, since Prestige is famous in Bangalore. Okay. So we have different apartments there, right? So LPARs are like apartments in one building, shared infrastructure, but private living space we have. CPUs, these are not generic CPUs. Okay, IBM Z has different processors types, different processor types for different workloads. Okay, this allows organization to run mixed workloads efficiently on the same systems. We have CPUs differently for Linux, differently for zOS, right? Memory, in mainframe, memory is called central storage. Memory is shared, protected. We all know, and every program run in its own address space. Address space is very important concept of the mainframe, and an address space gives each program a private, protected view of the memory. That's why one bad application, okay, if it fails, usually don't crash the system. And this is the discipline, another discipline, a major reason for the mainframe run for years without reboot. Input output channels. Here the work is handled by the dedicated hardware, not by the CPUs. So while input output is happening, CPUs are free to continue running the applications. DASD, direct access storage device. We know that. DASD is the primary persistent storage used by the zOS. Datasets, catalog, system libraries, all resides on the DASD. Most of the developers, when they see the datasets, right, that resides on the volume. If volume is offline, they can't be able to see the dataset. And that's where they need the help of the system programmers. It can be zOS or it can be the DB2 system programmers to make that volume online. So we have discussed this. We can skip this. CPC. You can just consider CPC as the black box. Okay. So LPAR. Let's go a little fast. LPAR, we all knows LPAR is not a something like VMware. Each LPAR has its own IPL, own palmlib. Okay. Consider LPAR as the one system or the second system. We can have many LPARs in one box, right? If one LPAR crashes, the other keeps running. That's the architecture of the mainframe. Okay. Everything we run on the zOS exists inside the LPARs. And if you see that in the top, we have PRSM technology. LPARs are implemented with the help of this. PRSM stands for Processor Resource System Manager. Okay. This feature, this is the IBM Z feature. Okay. IBM Z hardware feature. Okay. That allows one physical machine to be divided into multiple independent systems. So independent systems means LPARs. Okay. Each one of this system, okay, we told that is called an LPAR. Second is isolated OS images. Each LPAR run is independent zOS image. Okay, each image had its own IPL, own systhreads, own system datasets, and its own operators. A failure or IPL in one LPAR doesn't affect the other LPARs. Let's suppose you have a machine and you have divided into 10 LPARs. You can IPL any machine at any time. If that is a dev or if that is test and nothing critical is there, no testing required, you can make it offline also. You can shut it down for any amount of time also, and this will not impact the production one, okay, or the other one, okay, but those are running in the same machine. But for hardware, it's they know that, but for the ZOS, they don't know that they all are intercombined. So a failure or IPL in one LPAR doesn't affect other LPAR. We discuss.
Will the hardware will be shared between the LPARs, or that is also isolated? For example, I'm having a LPAR 1. Will it have a separate CPU, or it is the same CPU which is shared between the LPAR?
So let's suppose we CPU will be different, okay. CPU will be different on that point.
Can I take this question? It can be shared or dedicated. We can have dedicatedly assigned, or it can be shared.
So let's suppose you have like 20 CPUs available, and then you can define 10 CPUs to production, 5 to dev, and then 5 to the test.
Correct. And LPAR is the logical partition of the processors which are available along with the memory. So it forms a unit of system in itself which can act alone. And right, as someone pointed out, those CPUs or the processors can be shared amongst multiple LPARs. So it could be shared and it could be in isolation. Correct. And if one LPAR is going down, that is a virtual identity which is coming down, not the hardware component of it, right? It keeps the hardware is keep on functioning, it keeps on running, but that virtual system is coming down and coming up as a separate identity.
Okay, thank you.
One more thing I wanted to add, in LPAR is a logical partition. Anytime you can extend the memory or CPU, and you can bring down also number of CPU. If you assign 3,
correct,
can make it 2, or you can make it 4 or 5. It is a logical partition.
Yeah.
Storage, CPU and memory, you can extend.
Right.
Okay.
Yeah, thank you, Savitri. But just to make sure, we should give maximum CPUs to the production.
Right.
If we give like 20 CPUs to dev and 5 to production, business is impacted. Right. I mean, so you are very much right. I'm just taking a funny point here. Thank you, Savitri.
Saurabh, a couple more questions here. Sometime back you mentioned LPAR is not similar to how a VMware works, right? I'm just trying to draw a parallel here. VMware, I've used it about 10-15 years back when it was introduced. So it is like in the same machine, like you have your computer, personal computer, and on that you install this VMware software, and using that VMware software, you can create multiple operating systems, right? Like you can run one Linux, run one Windows, and all that. So the hardware is same, but it is using the same hardware for running multiple operating systems. That's what
your understanding is correct.
Correct.
Yeah, your
right?
understanding is correct. Very
So
correct.
LPAR is it not also similar? Like you have the same hardware, but within the same hardware, you partition that resources into multiple subsystems, if I can put it that way. Like for example, like let's say I have a SIT region, I have a development region, and I have a production region. So they all belong to different LPARs, correct?
Right.
But
you're right.
They could be sharing the resources of the same hardware or interconnected multiple hardwares.
Very right.
And that interconnected multiple hardwares is what we call as Sysplex, correct?
I mean, we will cover Sysplex, yeah, but your understanding is correct on here.
Okay, so I mean, how different it is from this virtual machines?
how it is different from virtual machines. We know about only on mainframes, but on the distributed.
I guess
Okay.
when Saurabh pointed out, he meant to say that these systems have their own operating system, separate operating system running, and most of the virtual machines in the containerization, if you see, they would not have their own operating system separately running. So I guess that's why he had drawn that differentiation, and I think that's the case here, right?
Okay.
Right.
I think it is second level hypervisor. There is two levels, right? LPAR is the hypervisor will be there. That is the firmware. We directly create LPARs. On top, in each LPAR, we have a OS. We can have a KVM or something. Some other virtual machine, second level virtual machine we can create.
Right.
Yeah, VMware is like that.
Okay. Okay. For now, I'll hang on. We'll continue with the discussion.
Correct. But in mainframe, this hypervisor is like PRSM is acts as a hypervisor here. But maybe that statement I can say like an LPAR is a virtual machine created by the hypervisor. We can say like PRSM. Each LPAR looks like a separate physical machine, has its own operating system, has dedicated or shared CPU and memory, as Savitri also mentioned, and it's isolated from other LPARs. Okay.
Okay. Yeah, thank you for the explanations. We'll continue with the discussion. I'll ask more questions if I have.
Yeah, sure. Okay, so means so where were we? Okay, isolated share Sysplex. Let's cover the Sysplex part.
Right.
Just 1 minute, please. So, what is Sysplex? I mean, you can say multiple zOS images in separate LPARs, right? Can work together as a single system. So this is called Sysplex. Okay, you can say like 10 LPARs acting as a one big system. Okay, all are running the zOS. So this is called a Sysplex. Now, what Sysplex help us in workload sharing, high availability, and continuous operation. From the business point of view, it feels like, I mean, we told that one big system, and we have different type of Sysplex also. There are two main type of Sysplex. Understanding the difference is very important. One is basic Sysplex, base Sysplex, and another is parallel Sysplex. So base Sysplex shares the data. Okay, how it is shared? I mean, multiple zOS system, and this base Sysplex can access the same DASD data sets. But if all the system are accessing the same DASD at same time, there can be a issue for the corruption. There can be corruption of the data. So then comes the parallel Sysplex that shares work. Okay, parallel Sysplex take this to the next level because of the why we got the need of the parallel Sysplex, because there is a huge amount of data available now. Data is oil. We are heading this term, right? Data is keep coming, keep coming all the time. Okay, in parallel Sysplex, multiple zOS systems run the same application. Okay, requests are dynamically routed. Any system can process any request, and from the user's point of view, they're talking to one system, not many. And how this is possible? Coupling facility. This was not available in the base Sysplex, but this is available in the parallel Sysplex. This will help. A coupling facility helps ensure no data corruption, no double updates to the members or to the DASD or to the files. So let's take example. 3 LPARs are running the Kix application, the same Kix application. Thousands of users log in. Okay, so automatically with the help of parallel Sysplex, with the help of coupling facility, workloads is automatically distributed across all the system. If there are 3 LPARs, if one fails also, right, the other system continue processing. You may not, or users may not even notice it. Okay, slide number 13, how LPAR works. We know that how LPAR works, and someone said some example also, and that was a real incident. If we say we have, let's suppose we have three LPAR. One LPAR was reported slow. Other LPARs on the same CPC, right, on the same machine, were behaving normally. When users reach out to application, they said, application team like you said that DB2 is slow. The DB2 team said the storage is slow. The storage team said that everything looks fine. So out of three LPAR, one is looking slow, but the rest two are working exactly fine. Now, how the system programmers will react and respond on this? We will look at the CPC wide picture. We know that this is same hardware, same storage, same network. So then question comes to us, what is different for this LPAR? The actual root cause, we discussed this also, right? The affected LPAR, which was very slow, has a weight of 10, and the neighboring LPAR, the other LPAR, has the weight of 200. So during the peak load, the higher weight LPAR was getting priority access to the CPU, and the slower LPAR was like in this starved situation. It's not broken, it's running, but it was very, very slow because of the weightage, because of the weights. So system programmer have to adjust the LPAR weights. Then once we did that, the CPU access normalized, response times stabilized. DB2 was suddenly fast again without even touching the DB2. So this is all about LPAR. Now these are the core building blocks of the zOS, and this is what matters to us also. For you, you have to see daily COBOL DB2, right? And for us, for the system programmers, we see BCP, we see JES2, we see WLM, SMF, DFSMS, and RECOF. These are like the control systems of the zOS. Okay. BCP is like it's very, very core. It's like the engine of zOS. It decides which work gets CPU, how memory is used, and how input output is handled. If BCP struggles, right, everything struggles. If engine is not able to get on, you can't do anything, right? So BCP is like an engine for the zOS. Just to we know that it decides which job starts, which wait, where output goes. When month and jobs are delayed or output queues explode, just is usually involved, and mostly just two. We are all using now just two. Just three is there, but in very limited systems. You see jobs waiting, but we in the backend look at initiators, look at queues, look at spool uses. Right? We talk about workload manager. Workload manager, it's like it will decide, okay, it's a core component of the mainframe, who is most important right now. Okay, if online users complain during batch window, WLM policy is usually the reason. Okay, system programmers have to tune WLM so business critical works meets response time goals. uh, how can we explain? Okay, imagine the Bangalore without traffic lights on the peak days. Forget about Saturday, Sunday. So WLM is like traffic lights for the mainframe. Okay, it decides what is important right now, and it gives resources to that task or that transactions. SMF is like it records what actually happened, each and everything it will record. Okay, it records anything. It's like a black box to the mainframe, like we have a black box for the planes, right? RMF, whatever data is comes from the SMF, RMF turns that raw system data into the something that we can understand. We mean system programmers can understand, or other system programmers can understand. When something is slow, right? When job is not running or something is slow, RMF is actually the tool which help us where and why it was slow with the help of the SMF data. DFS SMS storage management. It controls the data sets placement, space allocation, migration, backup. We all know that most storage issues, right? It don't cause the outages; they just cause the slowdowns. Rackoff, we all know it's internal tool of the security tool of the mainframe. It's like a how we can explain if we explain in layman terms, right? Rackoff is the security guard. Okay, it decides who can go and who can go in, who can go and who cannot go inside. One correct Rackoff rule or can block thousands of users or stop system task at any point, and it will be a business impact. USS, very important nowadays. Okay. Most modern tools that are coming in the market, zOSMF, DevOps, pipeline scripts, depends on the USS. USS has permissions. I mean, all those with respect to these, we need to grant some permissions, or we need to grant some space with respect to that. We ZFS files. I don't know. Many of us have heard about these files, vsum files, ZFS files. The ZFS files actually lives inside the USS. Okay, and it helps the mainframes talk to the metadata we have. So let's cover WLM in detail. Okay. I will not say this most important. Okay. So I mean, everyone should have got a point. WLM workload manager decides who gets priority when the resources are limited. Okay. Like two things are running, but WLM will decide which task, which job has the priority. Okay. Example, online transaction should respond within the 0.1 seconds. Okay, batch job must complete before a certain SLA we have been defined for that batch job. Critical work must not be delayed. Mainframe knows all, WLM knows all those things. We define a goal for that. Shall we give an example here, or shall we continue?
I think we have got a few more subsystems to be covered. I can
Okay.
probably.
Okay.
You can go ahead, complete till SMB.
That's fine. Probably you can go ahead now.
Yeah.
Hey, one of you guys are speaking?
Yes, Senthil. We were just taking a water break, quick water break. It's
Oh,
done.
no, that's fine. That's fine. As in, suddenly it went quiet. So,
Right. We have changed
yeah,
the
take your time.
scenes. Yep. We have no, that's okay. I'll be taking moving forward from here on for a couple more slides. So as Saurabh rightly mentioned about few subsystems like WLM, SMF, RMF, I'm just going to cover them in a bit more detail. To start off with SMF. So SMF is System Management Facility. It's a JS component that records system workload and resource usage data for performance analysis, accounting, and auditing. It's used for capacity planning, performance tuning, and problem determination. Up to now, we have talked about how a system is built. Now let's talk about how the system tells us what is actually happening there, right? So SMF keeps the records. So I'm not sure whether some of you are familiar with the SMF record types. It would have a number of records for most of the control blocks or the subsystems, for example, the DB2, CICS, storage, etc., wherein with those records, it keeps on recording all the activity which is happening in the system. And based on those, we can identify what has happened if, God forbid, anything goes wrong, right? So we can think of SMS as the black box recorder, like Saurabh said. It records everything that happens. If we say WLM is the brain of this ZOS, then SMF is the eyes and ears of ZOS. SMF continuously records what the system is doing, CPU usages, memory usage, IO activity, workload behavior, security events, etc. And when someone informs to us, system programmers, that system was slow last night, first thing we'll probably check is go and check in the SMF data. SMF does allow us to say exactly what, where, and when, and why anything has happened. Right. So just to give you an example, if a batch job, which normally finishes in about 30 minutes, has taken 2 hours in its last run, we will go ahead and we'll check in the SMF records what has gone wrong and why the job has taken a time longer than it was supposed to, right? So,
But
yeah.
Prabal here, I would like to add, like, Whenever job takes long time, right? 3 hours, 4 hours. Everyone has its opinion, right? Application team may say that okay, it's stuck in the loop. Database team may say that okay, something is not right. We as a system programmer may say that resources are constrained or not available to that.
Correct.
So SMF can help it us there.
Okay. So in short, SMF keeps all the records of the activity being happening on the system, and we can go ahead and check what's wrong if anything has happened to the system. If you could come to the next slide, please. Right. Next up is RMF. This is another important subsystem component of the operating system. It's resource measurement facility. RMF is a performance monitoring tool that uses SMF data to report on CPU, memory, IO, and workload behavior. If I have to put this in, I would say SMF is like I said, is the ear and eyes of the system. Then RMF is the analyst that checks or that will have its own findings about the whatever has happened wrong in the system. It takes the raw data and explain what actually has happened, right? When something is slow, RMF helps us check four things. First is CPU, another memory, then IO and workloads. And based on this, we can generate RMF records from the SMF data and tell what has happened in the system which was not supposed to, or where exactly the system has hit a problem, right? So I guess we have covered a couple of subsystems and zOS components so far. Now let's dive deep into our day-to-day work, how actually the work of a system programmer usually look like. So if you could go to the next slide, please. Right. So if you see here, these are some of the things we would check first thing in the morning, right? Which is we'll check whether the status of zOS looks fine. We'll check whether all the components, subsystems, major products, they are running fine or not, or if there are any issues reported, anything flagged. We'll also take a look into the JES and its subsystems, verify that all the jobs which were supposed to process have been processed fine. We'll also check about the resource thresholds, JES resources, and ensure that anything is not abnormal and the system is running and working smoothly as it is supposed to be. And if there are any abnormal behaviors which have been detected, then we'll go ahead and try to find the root cause of it and try to have a solution in place in order to come out of it, or to rectify it, right? So these are generally the things which system programmers would start their day with. Um, you would be wondering why a morning health check matters. So um, think of it this way: morning health checks are how system programmers protect business continuity quietly, consistently, and before anyone notices a problem, right? Most outages are not sudden. They could potentially be ignored warnings. For example, JES resource shortages. You would be seeing one resource in the JES which has been hitting the near threshold limit for some time, was not flagged, was not noticed, and it could lead to a major outage eventually. So that is something we have to be proactive about, continuously checking it so that no such scenarios happen, right? And business continuity can be maintained. Now, apart from this, next thing I want to cover about few more roles which RPS perform. If you would recall in one of the slides earlier, what Saurabh had presented, he talked about several job roles or different service lines, we call it in the mainframe world, which perform several duties, right? For example, hardware, DB2, CICS, etc. Similar to those, there are few more teams, those who are responsible for their own set of work, and they help us system programmers to keep the infra up and running. One of those important teams is the capacity planning, or we also term them as performance and capacity people, performance and capacity teams. That's a separate service line, and they use their own tools like SMF, RMF data. They also refer to. They also use SAS for their capacity planning, and they in this process they tell us that what, for example, say any of the weekend work or the month end work is coming up, they will have the capacity ensured so that the system is up and running to make to meet such peak hour utilizations, or say any major activity which is coming our way, right? So capacity planning answers one question: will tomorrow still work? And zOS built to run continuously for months and years. As a system programmer, we don't look at today only, but also how the system is growing over time. And they do help us in making those foresight assumptions, and we do rely on them to make and leverage on them about the month end and year end and major activities, whatever, say festive season or any major activity which is coming up, to plan and accordingly act, right? If you could come here. So this is how a peak hour analysis they do. I think we can skip this one. It largely talks about how the capacity planning is being done for the peak hours. They do see the growth trends, and based on that, they'll have their resources. They'll have a resource utilization metrics in place, which will be used for planning beforehand about the, for example, if we are supposed to make any weight change, etc., then those decisions can be taken well in advance, right? If you could come to the next one. Yeah, apart from the capacity performance and capacity team, another team which helps us a lot, geo system programmers, are the storage people. They are often termed as storage admins, administrators, or storage system programmers. And they are the people who are responsible for mainly the auxiliary storage that works on the systems. So the storage management ensures the availability, performance, and integrity of auxiliary storage, that is the tapes and SDs. They also manage the volumes, SMS. They take care of the SMS subsystem, HSM, etc. And they ensure that the storage requirements for the whole of the system is always met, right? So if I'm not sure whether most of you are aware of this or not, but DSD is the major in mainframe. DSD is the majority of the auxiliary data that lives there, along with the tapes. So in the earlier times, apart from the central storage, um, the auxiliary storage were mainly tapes. But as the technology advent happened, and we moved ahead, we also introduced some virtual devices which were capable of handling dynamically handling the much of the auxiliary storage, and they are termed as DESTs, right? So storage problems rarely crash the system immediately. They slow it down first, and but they are very, very important, and we need to be uh, on our toes to ensure that whenever we need any data from the storage devices, they are always up, running, functioning, and available to us, right? Another component of the important component of the storage system programmer's job is to take care of the SMS. So I'm sure most of you, when you were allocating your data sets, mainly the non-VSM data sets, could be a PDS or a PS, you would have been, while allocating on 3.2 panel, you would have seen few entries there like data class, storage class, management class, storage group, etc. And often we are told um, to just keep them blank, as the system will pick it up. And why system picks it up is because there is something working in the background which is called as SMS. So it SMS decides where new data will be placed automatically. Um, fast data goes to the fast disks, the volumes which are on the DHT boxes, and less used data often goes to the disks which are of lesser priority, could also be stored on the tapes. So we often, as developers, users, system programmers, we often don't choose our volumes where our data set is supposed to be residing, right? And this task is being done by the SMS. And people, those who manage SMS, are the storage system programmers. Apart from SMS, they also manage HSM, which is another subsystem or tool available to them. It's a tool which that it I mean, just understand it this way: not all data needs to stay on the disks forever, right? We HSM moves old or news data to cheaper storage, for example to tapes, and brings it back automatically when someone needs it. This does saves cost to our customers, and we ensure in this way that any data which has been migrated, HSM works it in a way that it will call it when we are looking for it, right? At times you would have noticed that when you are looking for a any of your data set, and it at the right end it says it is migrated, then there are queries which HSM can perform and to call it back. Some of it can happen automatically, and some of it are being done manually by the storage system programmers.
So many of us have done, even in the forum also, we have all the people, right? They
Right.
have done the HR recall, just recall the data sets.
Correct.
So this is all about HSM.
It is being performed. It is a task which goes to the HSM, which performs it and brings it back to us for our usage. If you could go to the next slide, please. Yeah. So apart from, say, DB2, CICS, performance and capacity, and storage, there's one more very important team, which is called as security team. We often termed it as RACIF team as well, because RACIF is an IBM security product, and you would notice most of the systems across industry using RACIF as their primary security product. So RACIF is an product that controls access to system resources through authentication, authorization, and auditing. While giving you the introduction about subsystems, Saurabh mentioned that RACIF is a security guard. I would say it's a security guard which has never been caught sleeping. So it is up and running and functioning all the time to ensure that system integrity is in place always, right? So, I mean, think of it this way: security is not an add-on; it's part of the operating system here in mainframe, right? RECAP decides who can do what level of authorization, authentication, or what level of uh, credibility will be given to for the data sets creation or deletion, and also in terms of programs, commands, auditing, etc. Right? Everything goes through RECIF. It decides. So it has its own components, RECIF classes, etc., wherein we'll decide what which type of user is authorized to perform what type of operations. Right? So RECIF is the product which is responsible for authentication, authorization, data sets and program protection, command control, auditing, etc. Apart from RACIF, there are two major security products in the market from the independent vendors. One is ECF2 and another is Top Secret, right?
Both belongs to Broadcom.
I think,
Yeah,
yeah,
yeah.
yeah. So now let's talk about something which is of utmost importance to us, the IPL. You all would have heard this term somewhere in your mainframe careers. I'm sure we are not confusing it with Indian Premier League here. It's initial program load, and to put it in simple words, it's the process of rebooting the mainframe LPAR. Remember, we are talking about the LPAR here, not the mainframe hardware. So IPL is the process of loading the zOS operating system in the central storage and initializing it. It initializes the input output definition configurations, that is the IODF configurations. It also initializes the zOS nucleus, which has the core OS code lying in it. and the control blocks. Apart from that, we also make several changes to the palm lib members if and when needed. So they get initialized with IPL if they can't be done dynamically. And then it also initializes core subsystems like JS, TCP/IP, your RMF, SMF, etc. All the core subsystems, CICS, DB2, for instance, they all get reinitialized or restarted when an IPL happens. Okay. So IPL is the process by which zOS is loaded into the central memory and the system is brought to a usable state after that. IPL is the most sensitive activity for us. That's why IPLs are planned in weeks or even months in advance, especially on the production systems, barring the need to do it as an emergency change. Is there a question? Okay. So like I said, they are often, not often, most of in the critical systems, IPLs would be planned weeks and months in advance, especially on the production systems. And why so? Because it gives a downtime to that particular LPAR. For example, if it is a production LPAR, it will be brought down for a stipulated time, which is decided well in advance. That often happens on a given time, which we call as change window. It's the non-business hours, either after the business hours on a weekday or often on weekends. A window of couple of hours, often ranging from 2 to 4 hours or a 6 hours for a major upgrade, is given to us, and only within that window we are supposed to perform the complete activity of bringing down that LPAR and bringing it up for whatever purpose we are going to perform it, right? From this point onwards, everything in that LPAR depends on how cleanly the IPL is performed. Okay. If I could take you through if I could take you through the step-by-step process of how IPL flows, I'll not go into much of a details. I'll just give you a high-level overview. The very first thing that happens during IPL is the hardware validation. So through IDF, it will validate what all hardware devices I'm supposed to connect, what processors, CPUs, chip aids, pitch aids, printers, etc. Right? And then it verifies all of them. And if hardware is not in a usable state, the IPL would not proceed further. Then once it is confirmed that the hardware, whatever it is looking for, it needs, is available to it, then the zOS nucleus is loaded into the real storage or the central storage, and it starts its own processing. After that comes the palmlib processing, wherein we do the twerking to the system, some of the important system parameters, right? And palmlib defines how the system should behave, memory limits, and WLM policy, SMF option, etc., subsystem parameters, etc. This is where system programmers define the personality of the system, is what you can say. Okay. And finally, the core system initialization. This includes JS, WLM, RACF, SMF, DB2, CICS, etc., or the other core subsystems or the core components of the system. Only after this step can applications and workload really start. And once, for instance, the TKS and TCP/IP is up, the users, be it you, us, system programmers, operators, all of us can actually log into the system, right? And if an IPL is done wrong, the system may come up, but it will not behave correctly. So we have to ensure that whatever parameters we are supplying to the system are being done as they are expected to, and then only we then only we can be assured of the system would behave the way it is supposed to do, right? Now you would be wondering, if this is such a critical um, activity and we keep on claiming that our systems have zero downtime, then why are we even performing it, right? So one important thing here is to understand is we do not do IPL frequently. There are often, out of our experience, even Saurabh would agree, there are even systems which keep on running for months, and there are customers who are truly reluctant of letting us give any downtime, right? Because their machines are functioning fine. But it is this IPL is required when changes cannot be activated dynamically, and we need an IPL to be performed for the system to pick up the major changes, whatever we are going to perform. For example, say we are applying maintenance to a zOS, then an IPL is needed. Or there are some nucleus level changes or certain palm lip changes which cannot be done on the fly dynamically, then we do need an IPL. There could be scenarios where hardware or an IDF change is performed or a system recovery is in place. Then in those scenarios also we would need an IPL, right? So if a change can be activated dynamically, that's okay. Then most of us would recommend to go it that way, not performing an IPL. But there are situations where there's no other option, but we have to take a downtime permission. It goes with a well-defined process to the system. Saurabh would be covering it. And then once given a green go, we'll plan it. And we have few parameters in place which we ensure are being communicated well to the operators or the stakeholders, those who are going to perform the IPL, and then we ensure that the IPL is being done. Now, you would be thinking, what is the role of a system programmer in the IPL? So we've got role at the multiple places. Before IPL, we validate the configurations of the palm lips, proc lips, IDF, etc., and ensure that everything is checked and everything looks good. We also ensure backups and fallback plans are ready and they're in place if, say, anything goes south, which is not expected. Right, during the IPL, we monitor the IPL process closely, and just before this, we also supply few important parameters which are called as load address and load palm. I'm not sure if you would have heard of it. These are two very important prerequisites for performing an IPL. In most of the accounts or the projects, how it goes is we'll communicate these parameters to the operations. Operators will perform the IPL, we monitor it closely, and we'll keep a check on the console messages, timing, subsystems are starting up, etc. We ensure everything during when an IPL is performed, right? After this, we do a post IPL verification, which is very critical. We do check the JS, RECF, SMF, WLM, connectivity, workload behavior, how is it being done. And only after validation, we hand the system back to application. So after all the core systems, subsystems are up, then only we ask the operators to start the initiator so that all the applications can come up as well. There are couple of types of IPL, namely three. One is cold IPL, another is warm IPL, and a quick IPL. Just to give you a short description of those. Um, uh, Cold IPL fixes the deep issues. Warm IPL preserves more of a pre-state where the system was. And quick IPL is when a minimal change is required. Every LPAR would have its own IPL. It's often defined or pre-decided by the customers or their architects based on their assumptions. And this is an important thing to understand that if IPL fails, nothing above it exists. There'll be no JS, no DB2, no. I mean, that LPAR, that particular LPAR will be down for that particular time, right? Yeah, so we have covered few sections now. Before we proceed further, if anybody has any doubts or any questions, please come up. We can take it along.
So this IPL for any production system, does it consider as a downtime, or there'll be a parallel system running which can take care of production workloads during IPL of one LPAR? How
Right.
does
Yeah.
that work?
Yeah, Vedanath, that's a good question. So it is a planned downtime for that particular production system. And what happens is that the load of that particular system would be moved to a sister system, a parallel system in place so that the production workload doesn't get impacted in most of the major accounts. However, there are few smaller accounts, those say have only one production LPAR. So we'll take this as a downtime permission from the customer that the system, the production will be down for these many hours when we are going to perform the IPL.
Okay, understood.
Yeah.
So, hi, this is Mohan.
Yes,
See,
Mohan.
this kind of system programming activities are much critical because it's directly related to the zOS operating system. So how you'll be performing the testing? Like, see, normally we used to have production like dev prod UAT, okay, and application point of view, okay. So will you be able to have a dedicated LPAR to test the changes, or you'll be practicing along with the application environment?
Right. So like yours, we also have production, development, and another LPAR, which is specifically for us is test LPAR. In some systems, it is also called as a sandbox system. So for instance, whatever changes we are making, will first ensure we perform it on a test system, because there's not many users using that system, and it does not have any production impact, any business impact. So for instance, say we are performing an upgrade or a maintenance to a zOS, we'll first do it on the test system or the sandbox system and ensure that it goes well as expected. And once we have got a clear idea that it's performing the way it is supposed to be, and there are no major issues reported, there everything would work smooth, then only we take it further to the development systems. Okay. And development systems also do not have the real users, I mean the end users there. It would often be your application programmers or the mainframe testers, etc. Right. So we'll then ensure that that the changes what we are trying to introduce to the system are looking good there also, and then only we'll take it to the production. So this is how we keep these checks and balances.
Thank you.
Yeah. Do we have any other questions?
I guess like you're saying operators will do IPL and you guys like system programmers will monitor the IPL. So how do you monitor? So I guess when the system is IPLing, you will not be able to connect to the mainframe or terminal. So do you have access to some terminal or console?
Yes, we have access to this console called as master console. And apart from that, there is an alternative. If you, I'm not sure whether you're familiar with this tool called HMC, Hardware Management Console. It also has its operating system level console available for us. So these are the two ways where we can continuously monitor the activity, what is happening in the system. And if we point out anything not going the way it is supposed to be, we'll pitch in and will ask the operators to take appropriate actions.
Okay, got it.
Do we have any other questions on IPLs or any other topic we have covered so far? If not, then Saurabh will take it further from here. All right, Saurabh, over to you.
Thank you, Prabal. Let's see what is the next topic. Okay. SMP.
Sorry, this question is related to the IPL.
Okay.
So you told about the 3 different types of IPL, right? So how you'll be performing? You'll be performing with the same program with the different parameters, correct?
Yes, largely that is correct. We have to make some changes in the configurations of the Palmlib which we are going to supply. So based on the type of IPL, we make those changes, but largely the performing the activity remains the same.
Thank you.
Yeah.
Okay, let's go to next slide. Okay, SMP. SMP is very important. I will say something like that. Any knowledge on SMP? Anyone can say anything on SMP? What exactly it is? What it is doing?
For mainframe.
So SMP is used to install the software. It's more like a software management program.
Right.
Say this app store for mainframe.
App
The
Store, no.
It is
Okay.
used to install various ISV products
Correct.
and do the maintenance.
Correct. So, yeah, I think it was Navneet, right? So, App Store, maybe in App Store, now we will get the app applications there, right? We know that, okay, I want to install Outlook. Outlook is there, right? But in SMP, we have to bring the package from the outside and then we can install it. So, nothing is available. We have to feed the SMP.
Mhm.
Is it right, Navneet?
No, I mean, I don't know. I'm not a system programmer.
Okay.
But
Okay.
I have few questions, okay? Like maybe when you cover this topic,
Okay.
kindly try to answer.
Yeah, sure.
So,
We will take
so
it.
like you said, right? Nothing is available, and you need to go get it from somewhere and use this SMP for installation.
Correct.
So let's say there is a fresh software. For example, let's say you are installing DB2 engine in your mainframe for the first time, hypothetically.
Okay.
Okay, so you need to go get it from some source and then install it. So how exactly does it happen?
Right.
Like you use
You're
FTP,
right.
SFTP, that is one thing. And the second question I have is, there is something called PTFs that I came to know. It is like
PTFs.
patches for the software,
Right.
right?
Right.
The upgrades, the
Right.
upgrade versions. So like let's say IBM provides, like I do not belong to IBM, but
Okay.
I run my business on an IBM mainframe.
Okay.
So when IBM releases a patch version, like
Okay.
how do I get to know? How do I get to know there is a new upgraded version, and how do I install it? These are two basic questions I have.
Okay. We will cover this, Navneet. Thank you. So let's go with the first of all basic definition of SMP. So SMP is a core zOS a system tool. It's internal. It's provided by IBM itself. Okay, it's come with the zOS. No need to install it separately. It's coming internally with the zOS. Okay, any changes to the zOS, okay, any changes to the ISVs, we have the mainframe applications, the products running on the zOS, fixes, upgrade or maintenance, these all must go through the SMP. There is no other alternative for that. Okay, so rightly someone said that it's act as a change controller for the operating system. Okay, so at very high level, if I say SMP does three things, okay, and it does them extremely well. Okay, it install fixes. Fixes means the PTFs. Okay, someone said something about PTF. Okay, it tracks every change. What is happening when we are installing something, when we are getting some new modules, when we are deleting some new modules. All those things are being tracked by the SMP. Okay, and most importantly, it protects the system integrity. Okay, SMP only ensures us to that the maintenance or upgrade or anything is being done correct and consistent. All information stored in the SMP. Okay. Uh, okay. Install change tracking. Okay. Let's talk about with respect to SMP, we have sysmods. Okay. So maybe we can talk about sysmods. There are different types of sysmods we have FMIDs, we have then we have PTFs, then we have APARs. Okay, so we will talk about these also in with respect to this in the SMP.
System modifications. So these are the patches or types of patches you can say.
Yeah. So if you talk about sysmod or FMIDs, it's like the number given to any product which SMP can understand. So let's take a very layman example. In the class, everyone knows our name, right? But still we have been given a roll number, right? But roll number is very unique. We can't have a same roll number to any other person. We can have Saurabh two Saurabh, three Saurabh, four Saurabh, but we can have only one roll number to me. And school knows my roll number. School don't doesn't characterize me with the name, but they characterize with me with the roll number. With my roll number, every information comes. Similarly, FMID something like that. And then we have PTFs. PTFs are like you can say the permanent fixes provided by the vendor. Uh, PTFs can also act as enhancement. Okay, if Navneet is there, okay, Navneet wants some new application, some new features on his running IBM product or any other vendor product. So we may release PTFs for that. Okay, And IPARs are temporary fix. If Navneet is facing any issues in one of his product, and it's very major issues, and it needs to be resolved very soon. So we as a team, not we, maybe software developers, I will say IBM team or other vendors team will release a IPAR, a temporary fix for that. And once that fix is done, later in the time it will release PTF for all, because that issue may not be for me, but it can come later in the term. Because why it is not coming for me now? Because maybe my system is behaving differently, maybe my I'm not using that functionality which Navneet system is using, but later in the terms I can use that functionality, and I can also get that same problem error. So in order to resolve the future errors or the known issues we have, the companies, the vendors are releasing the PTFs for that. So PTFs are patching, or we can say like that, plus PTMs are the new enhancements. Okay. Now, if you go to the SMP, right? So
This was Navneet's question. How is the process being done?
Okay. Yeah. So Navneet has second question also. I think he wants to know how we know that the PTFs have been released.
Yeah.
Okay. So it's
he wanted to know the process, the
okay.
SMP process.
Okay. So till now we are clear what is SMP. It's a core tool used to install the maintenance, the upgrades. Okay. SMP knows everything. No need to remember anything manually. SMP has all the information with respect to that. Okay. Now the core concept, if we say SMP, uh, how the information is stored in the SMP with the help of the CSI. We always heard global CSI name, target CSI, or some other distributed CSI. CSI is like CSI doesn't stores the code. Okay, it stores knowledge. What knowledge? What is installed? Which version? Which fixes? Which depends? What depends on what? What can be installed safely? And SMP in exactly read this CSI. Okay, you can't go to SMP and you can search for any. You can't search for anything. You have to give the CSI name, and then only the information comes in front of you. If you don't give the CSI, SMP is like a normal application or normal ISPF screen for you. You can go. You may not be go anywhere. You can just see, okay, 1 2 3 4, but you can't use those functionality until and unless you are giving the CSI manually, the name of the CSI there. If Navneet wants to know the DB2 CSI, DB2 information, what is the version has been installed, what are the FMIDs have been installed, what are the PTFs have been installed, those all will be stored in the CSI. And you have in the SMP panel, you have to give the CSI name, and then SMP will show you all the information it has. Okay. And CSI can never be wrong. Okay, you have to make sure that your CSI is correct with respect to your latest maintenance. Okay, now we have zones also, that is global, target, delib. The global zone is where the knowledge lives. Actually, knowledge means dependency, relationship, whole data. If I say whole data is something like extra information given to you by the vendor. If Navneet wants to apply one PTF, but before applying that PTF, we have some hold actions. Okay, for developers, it is hold cards. For us, it is hold actions, hold data. Okay, so vendor is telling Navneet, okay, before you apply this PTF, please increase the space, or maybe after you apply the PTFs, please do the IPL, please do the linked list update, or please do the LLA refresh. Any information, any extra information that needs to be done after the PTF apply or before the PTF apply, that contains in the whole data, and whole data lives in the global zone. We receive the whole data in the global zone only, and it's come automatically with the patches you are receiving. Okay. So, and second is target. Target zone represents what the system actually runs. These are the actually libraries, okay, which actually runs the product. Okay, these are in some systems we call these target zones or target libraries are the runtime libraries also. So runtime libraries and target libraries are same. there is a slight difference. So runtime libraries are the libraries which are actually running on the client system. Target libraries, you can say something like SMP target libraries. Okay, but these both libraries, target libraries and the runtime libraries, should be in sync.
They
Okay.
will be of the same version.
Yeah.
SMP will contain the latest libraries,
Correct.
which are then transported to something called as
runtime libraries.
which will actually run the
And
product.
correct. And if you go deeper, then we have a need why you need runtime libraries once you have target libraries placed. So there is a difference, because if we want to do maintenance, where we will do? We can't do directly on the runtime. We can't shut down the product for the client.
Right.
We can't shut down the application for the client. Okay. So that's the reason target libraries, runtime libraries should be in sync. So we do first change on the target libraries. Then in the time of change window, we just copy the changes from the target libraries to the runtime libraries. We we are doing the changes before the change window. Okay, because we have the target libraries that are in sync with the runtime libraries. We do the changes, we apply the changes. Okay, and then at the time of change window, we just copy it, and after copying, we will just do the test of the product, and if it run fine, we are okay to go. So just remember, if you want to run the product in a client system, you need the runtime libraries or the target libraries. The difference.
Saurabh,
Yeah.
Prabal, I have maybe this question is little basic, but help
Yeah.
me understand. You do a product upgrade, let us say using SMPE, and
Correct.
the same product, same DB2 version, let's say, is in multiple LPARs. What actually happens in the background? Because your CSI will have, one mapping stating that so and so DB2 version is present in this LPAR, correct? But if the same version needs to go into multiple LPARs, what actually do you do on the job?
So we will have common CSI for all the LPARs. Okay, we will not maintain the separate global CSI I'm talking. We may have the different target CSI, and every LPAR may not be in sync also. So maybe in QDev LPAR, let's suppose we are on version 12, and in test or in we are on version 13, and in prod also we are 13. So we are maintaining different CSI, and we have a factory, you can say, LPAR to us, where we will actually do the changes, where we will maintain a base copy, and then from base copy, and then we will transfer those changes to the different LPARs, whatever we need. Okay, if version 13 is needed, we will go to the factory LPAR. We will do the changes on the version 13, and then transfer the impacted libraries. Okay, with every PTF, with every APAR, with every FMID, we have some data sets got affected, not all, some. There may be a 10 data sets are needed to run the product, but while doing the PTF apply, only 2 3 are actually got impacted. So we will transfer only those 2 3 data sets to the needed LPAR, and then we will copy it at the time of change window.
Right. And to add to what Saurabh said, so if I'm getting your question correctly, you are asking like how it is being done on different LPARs. So we'll perform the SMP operation on one LPAR, say on our test LPAR, which has the SMP available to us. We'll roll out the changes there, take the product to the next level version where we are looking it to, ensure that looks fine. Now we will take those data sets to a different LPAR, and that would be a separate change. If we are taking it to a development LPAR, then it would be done separately. We'll perform the change there. If it requires, we'll perform an IPL there. And similarly, we'll take it further to the different LPARs in form of different changes. So for example, if we have got multiple production systems, we'll have multiple changes planned for there, and one at a time. This is how we approach one LPAR at a time. We'll roll out the change, and then in the next time we'll do it on the next LPAR.
So let's
And
suppose
each of those LPARs will have its own CSA.
Yeah, you can access all your LPARs on the HMC.
But Senthil, the best practice says to us that let's suppose we have 3 LPARs. Maintain the SMP, okay, on the test LPAR, okay, the original SMP, and then do the changes, do the upgrade, do the PTF apply there. See what is getting impacted. If you want the same changes to be transferred to the QDev, to the prod, copy those impacted libraries, do the FTP, or if data is shared, if volume is DSD is shared, no need to do anything, just copy it. So we will maintain one copy, one base copy, that is the SMP copy on the test LPAR. We will do the changes there. We will have all those original changes there, do the changes, apply the PTF, see what is impacted, and transfer the target libraries to the QDevel parts, let's suppose, and at the time of change window, just copy the runtime libraries to target libraries that has been transferred to the runtime libraries we have on that on that running LPAR.
But
So
where is your documentation? Where is your documentation that says, so you have, let's say there are 3 LPARs, just to keep it simple, L1, L2, L3. L1 is where you applied all this. And for the L2 and L3, you are doing a manual copy and putting it into target libraries.
Correct.
But this information, it exists in your head, that I'm not questioning. I'm asking, in the system, where do you know, how do a developer, for example, know that when are you pushing it? Did you push it? How do I know? Instead of finding out from the product, how do I know? How do auditors know that you are pushing it into these target libraries?
So we will do it with the help of change record.
And it goes through the CAB approval cycle. So there will be a CAB call where all the stakeholders would be present.
Okay, that is the process, right?
Right.
But on the mainframe, you should have one source of truth, which I thought was the CSI, is the CSI.
Yeah,
where
right.
Ideally, you should have a list of all the LPARs present, and in each LPAR, what are the versions of the products present, and the software that you have loaded and which version it is. Is that not right?
So this is right. With the help of CSI, you will get all those information. But there is no need to maintain the CSI for each separately for each LPAR. It depends system to system. But there is no need to maintain separate copy for production, separate copy for dev, separate copy for test. You can have the same copy,
Are you trying to ask whether CSI contains the information of a product? I mean, the level at which it is on different LPARs.
Correct. The CSI can tell me which LPAR has which version of this product running, including at the PTF level. Can it tell me exactly what is running? Like if I had to take a snap at your system without a system programmer's help, let's say I want to do it as a programmatically, can I read SMPE to understand which LPAR has which data, which version of this running?
No, for that you'll have to go check in that particular LPAR and see what is the present status there, mostly from the logs.
CSI will help you only with the product information. CSI will not help you with the, okay, this is A LPAR, and on A LPAR, this version is present. On B LPAR, this version is present. CSI will give you from the top till the end, the product information only.
Okay. So I think I understand that. I really don't think that makes full sense to me, but I get what you're saying. So one follow-up question before you answer.
Yeah.
So you have 3 CSIs here. What can you again tell? What is these 3 CSIs? So
yeah,
targets.
Yeah. And Senthil, if you, let's suppose you're on A LPAR and you want to see which version you are on, and you don't have the CSI copy maintained here, a CSI copy is in the test LPAR, you have only the runtime libraries, then you can go to the runtime libraries to load libraries. You can just go the browse and see the FMID or see the program number or the version. You can get the information there. Or if you know the started task, go to the started start in the SDSF, open that started task, and it will tell you which version you are on.
Yeah, that I get it. Yeah. So the products themselves will have something like, if I have Python, I can say Python hyphen version, and it will tell me what Python version it's running. But can I get it at the, okay. So you in the CSS, what you're saying is, when you do a receive, it goes to the global zone. When you do apply, it goes to the target zone. When you accept it, it goes to the distribution zone. Is what you're saying. So that's not at LPAR level. That is at the, like you are maintaining CSI for all the dev LPARs, one CSI. Then that CSI, when you receive it, there is a global zone CSI where it is. When you apply it, it is in a target zone CSI.
Correct.
And when you accept it, it becomes distribution zone. So if I understand right, when you get the PTF from a vendor, you put it in receive. Like first time when you want to apply the PTF, you'll put it in receive. When you actually want to apply it on the target system, you do an apply so that it basically installs. So
Very
receive
right.
is like you receiving it from the vendor to your shop. The apply is
Right.
where you actually apply it on the target environment.
Right.
Accept is where you have decided, okay, this is good state for a couple of weeks it has run, and I'm now accepting it to the place that I'm not going to roll back and a thing. Till that point, I keep the thing. I can go back to the previous state, but then I accept at that point and say, okay, but now we tested it also and it works, so I'm accepting the PDF into my system.
Very right, very right. I mean, if we want to follow the best practice, okay, we always accept the FMIDs, sysmods. We don't accept the PTFs, and there is a reason for that. Today's PTF, which has been released today, it can be a good PTF for the next 6 months, 1 year, 2 year, but it can become a PE, problem in error, at any time. And once we accept it, the PTF, we can't roll back.
Right.
Okay, then we
Yeah,
have to apply
understood.
some other PTF. So
Yeah.
best practice to the system programmer says to us, don't accept the PTFs, because to run the product, you need the target libraries, and target libraries are getting generated with the help of the apply. We are doing the accept just to maintain the clean reference fresh copy, and it can be used for the recovery. Okay.
Yeah, got it. Yeah, got it. Okay. So somebody else is going to ask question and I interrupted them. I don't know who, but
yeah. So Navneet, questions one thing, how we will bring the package. So we will go to the vendor. Where every vendor has different jobs, you can say, or method to get the electronically relative files, I will say. These are the electronically relative files, the SMP files, which actually build the product or build the package, contains the information. So we will go to the vendor. Let's go to the IBM vendor. For IBM vendor, we have a ShopG tool. That's a marketplace, we can say, Navneet. So ShopG, you can go there if you have the access, select whatever product you want, and then ignore the billing cost. We will not take that, all those things. Order those product, and on or through on your email, you will get an email. Then you, with the help of FTP, with the help of the job, you can receive that product in your system, and then you can extract it with the help of the SMP, with the help of the set of jobs. So probably we will first do the extraction, and then we will do the receive. As Senthil said, receive means you are receiving the package, and then apply, we will do the, before apply, we will do the apply check. It just like apply check means you are just testing the things before going for the actual editing. So then go for the apply, and then accept check, and then go for the accept, and you are ready with the SMP thing. But after SMP thing, in order to run the product, there are configuration changes you need to do. We have a program directory with respect to IBM products, where all the changes, whatever we have to done to the system, maybe in the palm leaf or maybe in the proc leaves, we have to define the started task. We have to give some rack of definitions, rack of access. We have to define some new classes, started task, all those things. These are comes under the configuration changes. Once you do that with, and you are not doing it means like randomly, there is a program directory means there is a book given to you, PDF format, how to run this product, how to make this product active. After the SMP will not guarantee you that you can run the product. It is just you have the product available with you, you are all set to run it, but you have to do some changes before you run it in the exact way whatever you have the demand. So that is the configuration changes we have to do, and that is well written in the form of the program directory for the IBM products, and you can see whatever actions you have to do there. Once you do that, you are good to go with the product. You can test it with the help of the IVP. IVPs are like verification jobs. It's if I say in layman terms, it's like before we go for a how can I say, before we go for actual car to buy, right, we always take some test drives, right? Okay, this is nice, this is nice, okay, all looks fine with respect to my expectation, and then we buy it. So IVP is something like that, verification programs given by the vendors to the system programmers, so that you, before you run the actual product, you can run the IVPs, and if IVPs ends with condition codes of 0, all are set to go. You are open to run the product, and you are open to give it back to the business with the expectations they have.
Right. And I think Navneet also wanted to know how are we getting informed about any new release or any new maintenance.
Right.
So Navneet, to answer that, we often subscribe to all the vendor channels. We get of email notifications from them about the, if it's either us or the customer who gets the intimation from the vendors about any new release of their product or any new maintenance level. Alongside, there's also one more way. If, for example, we are doing any major upgrade, say a zOS upgrade, then we do a compatibility check of all our products and subsystems. For that, we have to go and check whether the level of our products and subsystems where we are currently, will it be compatible to the next level of OS we are going to move to. And for that, for that compatibility check, we'll go to the various vendor sites and ensure that we have the latest or the compatible version of the products which would fit in when we go ahead with the OS upgrade.
And if you go a little deep, means there is a cars level for the Broadcom products, RSU levels for the IBM products. With respect to this, you can get your maintenance level, to which maintenance you are there. Okay, is it like 6 months back, 4 months back? Along the third method is like you can run a job, SMP job, and you can get a list of PTFs there, uh, transfer it into the notepad. Means in the sense like you will get what are the PTFs have been applied. You can run the SMP jobs for that. uh, Transfer that into a notepad, give that notepad or XML file to the vendor will say to you, okay, you are at this level and this much of PTFs you need to apply in order to be on the latest maintenance. And latest maintenance doesn't mean that, okay, Senthil wants me to apply the latest maintenance. Saurabh, can you please apply latest maintenance to this product? This product is very critical to the business and we don't want to have any level of we can say any incidents to this product, and we want new enhancement, new features also for this product. So I will say to Senthil, okay Senthil, I will apply the latest maintenance, but I will not apply for till 9th of Jan or 10th of Jan. I will apply 4 months back. Maybe I can apply till October, till September. Why? There is a reason for that, because those are the tested PTFs that has been running in the system, not my system, but other systems, any client system for the past 4 or 5 months, and no problems have been reported to the vendor. Those PTFs which has been released yesterday, day before yesterday, or 1 month back may not have been applied by any other customer, and it can have a problem, right? So there are 5%, 2% chance that PTF can cause a problem. So that's the reason.
One
If
question
someone
there.
says, yeah,
If everyone thinks like that, then the latest version will never be tested by anyone, right?
you are right, but I don't want to go to the latest. Business means critical to
It
me.
would be tested at multiple stages, but we are here talking about the criticality
Best
of our
practice. Yeah,
criticality of our production system. Imagine this is, say, you are working for a banking
Got it.
system, which cannot even afford to have anything going down for 5 minutes, right? So these are the best practices which we follow here just to ensure the continuity of the business operations.
Got
but
it.
your thinking was right, Navneet. I like it.
No, so I mean, yeah, I mean, as system programmers, maybe you will be downloading it and testing it in your test LPAR
Correct.
or somewhere before applying it to production, kind of. That's what you mean, right? So you will
Yeah, yeah.
directly not
We will
upgrade
not.
any production subsystem. Okay.
Yeah, correct. But there are few systems that only have production. I've seen those systems also.
Oh,
So
okay.
at that time we have to apply it. But again, even we apply it on test, QDev, system programmers have to make sure that there are two things. If Navneet is going for the change for a maintenance, Navneet will think on two perspective. One is, okay, my change will go fine and I'm fine. I'm done with the work. Second, what if my change doesn't go fine? He has to make the plan for that also. How to roll back,
Okay.
how to come back. You have to be 100% correct on both the approach, because
Got it.
system is, I will say very layman term, system is system. The deeper you go inside, the more you will get, but you will get only when you just touch it. Okay, and you are touching it at the time of change window only. We can bring our experience, all those things, but there's still many things on the system side.
Got it. Yeah, thank you,
So
Saurabh.
thank you, Navneet. Okay, so next slide. I think we are good with the SMP. We can have more mm, deep session on the SMP if anyone wants on that. But let's go to change management process. Just we can see the slide and we all knows about this. No need to see. We just now discuss with the help of the Navneet example also. If we go to the next slide, right? On-call life of a zOS system programmer. This is where the experience matter. And on-call means uh, uh, responding outside business hours, right? There is no business hours for a on-call person, and that is means making fast, high-impact decisions at the time of on-call. You have to protect the availability and the business continuity. Even though you receive call at 2 a.m., 3 a.m., 4 a.m., your primary focus is to make sure the business runs as soon as possible. Okay. As zOS, we know that 24/7 system programmers, be it any system programmers, is also 24/7. Okay. If something breaks at any time, the operation team or the other team, everyone knows the phone number of the particular responsible person. I will say, or it can be a hardware person, it can be a zOS system programmer. It can be we all know we have primary on call and then we have secondary on call. So everyone knows the phone number and we have to be available all the time on that point. So whenever on-call starts, right, on-call never starts with a clear problem statement. Let's suppose I am Saurabh and I'm receiving on-call at 2 a.m. I will not say, okay, this is stuck, this is not running because of this. We have seen this. Can you please look at this? No, they will say just one word to us: system is slow. Can you please look at this? My jobs are not running. Can you please look at this? Jobs are stuck. Nothing is working. Can you please fix this as soon as possible? And that's the time actually the pressure comes. Okay. So our first job at that time is not fixing, it's understanding what is exactly actually broken at that time. Because one wrong movement at 2 a.m. at 3 a.m. can cause a 24 hours outage also. So we mean system programmers or any person who is handling the on calls, right? They have to be very calm on their approach. So most on-call incidents fall into four buckets with respect to the zOS system programmer. Number one is SMF full. Number second is storage full. Just two spool issues, security issues. Okay, different systems with respect to different problems, but the outcome is similar: business impact. If you go to SMF, right? So we have understood SMF is like black box recording everything. Okay. So if let's suppose with respect to SMF, so we have some SMF data sets, okay, that is defined with the name of sys1.main1, main2, main3. Let's suppose at the time of night, SMF recording stops, okay, or switches fails. Automatically the switching happens from one data set. If it is full, system will automatically switch to second from second to third, and then from third to one. If let's suppose SMF recording stops, RMF will not work. We can't get the RMF reports. There is no use of that tool because RMF depends on SMF raw data, right? Uh, if someone wants the auditing data, if someone wants the billing data, okay, that is also lost with respect to that time period. From where we will get the report? We can't get the report, right? Performance analyst, someone will say to me, okay, sort of this system is running slow. Can you look at that? Why? I will look at the SMF data and then with the help of RMF, I will analyze. But this is also stop. This can be a dangerous situation. Okay, that's the reason we have on call for this type of thing when SMF data reaches the capacity. Okay, so
Hey, Saurabh, one time check, okay? We are already past the 2 hours, okay? So, and I did see a couple of people who dropped, but not too many. So maybe we continue this for another 10-15 minutes. But if I see people dropping, or if people want to stop here and do it in another session, please put it in the chat or then say, and then we can see, right? I don't want to keep continuing if people are not interested. So yeah, you go ahead and maybe somewhere in the logical point, we can stop and ask people whether they want to continue.
Okay. Thank you, Santil. Now, if I say how the SMF volume increases rapidly, right? Maybe in the night when we have the batch load workload increases. In the night, we all knows, be it system programmers, be it developers, be it anyone. We have the month-end jobs, we have the long-running jobs, we have the billing jobs, we have the reporting, heavy reporting jobs, we have the backup activity jobs, cleanup jobs. Okay, with respect to this, sometimes the SMF volume increases rapidly. Okay, so we all knows what happens when SMF reaches the capacity. Can't write new records, dataset switching fails, SMF recording stops or become partial. This will not crash the system. Okay, this will not crash the system. Business will run, but it is dangerous. It's like, you can understand, it's like the mainframe is running, but it's running blindly. Okay, we don't have the data to prove something. If someone comes to us, if in the morning the security team ask me for the logs, I may not be able to provide him. Okay, if finance team ask me why is the batch CPU users not matching my billing, at that when the job was running, maybe that when the job was running, the SMF was not capturing the data. I'm not able to answer those questions. Okay.
Saurabh, I have a question here. Like, see, like for a syslog or like for a scheduler mlog, we used to have, whenever the log is full, we will be creating another data set and it will automatically writing that one. Okay, a backup file will be there. Whenever the one of the log file is full, we start writing on the next file. We won't be
Correct.
having the same kind of
So
setup in SMF
yeah,
logs.
here also we have three data sets: main one, main two, main three. But what if the switching from main one to main two is not, didn't happen, or all three data sets got full, and there is a huge amount of workload or volume is coming, or maybe on that volume where SMF datasets resides is out of cylinders. We don't have space there, so SMF datasets can't grow rapidly, or can't look for the space. At that moment, we have the SMF problems.
Right. It should
We
be
have
dynamic, right? Switching of the SOC.
Yeah.
As you said, one problem is that switching, if it is happening, that is fine.
Yeah.
But when you are telling that there are three SMF log means it's a static, right? Not it is a dynamic one. Whenever one log is full or 80% is full, we start writing.
When one log is full, system automatically switch to the second log, second data sets. When second is full, it will switch to the third. When third is full, it will back up the first one. It will store in some place and it will go to the first again. Let's go to the second slide. Storage full. We all know that once a SD volume is full or near full, if Mohan wants to create some new dataset on some particular volume, he will not able to. New dataset allocation fail. Existing datasets cannot extend. Log writes. It can be you can relate this issue. Log writes, right? It will fail because we don't have the space there. We have seen many jobs events with the space related problems like SB37, right? Um, uh, if we are going for the transactions and transaction is going to some other volumes and that volume is full, so transactions will also get hang or fail. So this is with respect to the storage thing. One means any volume, if one volume is full, it is dangerous. Okay, one volume can impact many systems. Okay, those volumes can be related to DB2. That volume can be tied to the IMS. That volume can be tied to the transactions. So okay, application starts bending. So now how we will handle this? Let's suppose it comes to us. So we will free the space, okay, restore the allocation, stabilize the critical workloads. How we will free the space? We will move the dump files if we have, or some other files that has been not been used, temporary data set, something like that. We will archive those data sets. Okay, we will, maybe we can remove it also, right? We will clear the old work files if we have something there. If we have some files that are not critical to the system or that is not needed now, but it's on there on that volume, we will delete those. We will delete the expire or the obsolete data sets. We will offload the completely logs. Okay, we can take the dump of that particular log, particular data set that contains the log, and restore it in some other volume, and then come to this volume and delete that data set. So once space is available, then allocation will start automatically with the help of the features we have like SMS and all those things.
One question I have.
Yeah.
How about the volume recovery? So actually, in one of my case, I have a strange issue. Like,
correct.
We could not able to mount the volume, so we lost the data. So what is the precaution we need to take in order to
see? I also
kind
have
not happening.
faced this issue, Mohan. So there was a complete outage in one of the data center, and when the after that outage, when the system is given to us, we lost many volumes. Some volumes were not able to map to the hardware and not able to define something. But with respect to our knowledge on this site, we always just keep the volumes offline, online. We will try with that approach. But if something a volume is lost, then this problem will go to the storage team.
Storage team, they'll do
they
the
will-
recovery. They have their tools. Could be an HSM recovery or other tools what they use, and they have their of backup and backup jobs running on a daily basis, weekly basis, when they can get you
correct.
The last version of that volume or the data set. They can fetch it to you,
Correct.
but there could be a possibility that after the time it was backed up and before the time it was lost, there could be some data which could have gone missing, and that is a real life problem we have also encountered.
So DB storage team can help much more on that, because we don't have access for dive deeper into this. But if let's suppose if Mohan is not able to see some data set, so what first thing he will try as a system programmer? He will see whether volume is online or not. If it is offline, he will try to make it online. If he is not able to make it online, he will see some other status, and then he will go to the I think ISMF is the
ISMF.
yeah, it's similar to ISPF tool that is given to us. We can see the volume status and all those things,
Right.
how many volumes are what volume at what level are free and all those things. So we will try to make it online. We will see the status, we will see the UCB, and then try to make it online. If we are not able to do anything there, and then we will reach out to the storage team. And yes, there will be.
I have one more question. Like, see,
Yeah.
if you take in the cloud environment,
Yeah.
they'll be storing the data in different clusters. Okay, different places they used to store the same data. Okay, like some storage will be costlier, so they'll be having the backup in some other place where they can retrieve. In our case, are we following any kind of practice like that? Because in one of our case, we lost the data, we could not able to recover where one of our tool was there.
So you lost the data on the prod or on the QDev?
No, yeah, even in prod. Actually, that is a tool which we had was residing in one volume that has been lost. We could not able to recover.
That's quite strange, because usually the practice is to keep a backup of the important data on a secondary auxiliary space available to us, could be on tapes, for instance. So in most of our systems, what storage team would prefer doing is they'll have a continuous backup of the important data to some other devices, say tape volumes, etc., wherein they can be fetched if the primary data is lost.
But
Yeah, Mohan, go ahead, please.
No, in our case, it's different. See, actually, we used to have the backup, like based on the qualifier, they used to have the backup.
So what was that
But
backup also?
the thing is
Was
that
that backup also on the DESD device where the primary data was stored? Or was it on a separate?
No, I'm not sure about that. The
Yeah.
thing is that there was a backup for that primary qualifier. There was some new volume which has been installed. Due to that, the catalog was there, but we could not able to access the data.
Okay.
That happened. So actually that storage area, I think we could not able to mount.
Hey, I'm sorry to interrupt. Okay, I think you guys have to be taking some of it offline. Okay,
Right.
Not get into deeper into one of the issues, right? So when let know it. Right?
Yep, sure,
Sorry.
Santil, agree. Mohan, we can connect offline and discuss that.
Yeah, sure. Thank you.
Yes, sir.
Okay. Let's go to the next slide. Just to spool issue, we all know it, we will cover it very fast. What do you mean by this issue, spool issues? If we have a spool full, jobs cannot enter the uh, system, I will say. Outputs cannot be returned. Operators see the job submitted, but they are not running. Application developers or developers see the jobs running, but that is in loop, not running. Job is stuck in the input. And then we have a common problem, batch windows starting missing the SLAs. Every job has a SLA, production job has a SLA tied to it. Okay, so how this will come to us in the night? Hundreds of job waiting, operators escalating this urgently, business asking, someone from the application team or the business team asking to us why payroll or billing cycle hasn't finished within the SLA. Okay, why my job is not running? SLA has been breached. Okay, the business will impact. Okay, so once spool is filled, we know that everything waits. Okay, the fastest way to recover to reduce spool uses is very high level actions, I will say. Stop or hold runaway jobs. Identify the jobs that is in loop. Maybe someone is doing testing and someone has run that job, but that job has went into the loop from the past 5 6 7 8 8 8 hours, and it is causing, and it is using the extreme amount of resources and also filling the space. Okay, so we will purge the unnecessary old output. We will purge the test jobs that are there. Every jobs has a name tied to it. We identified, we characterize the jobs with the help of the name. We know that this is production, we know that this is test job. So we will purge the test jobs, we will purge the production jobs that are sitting in spool from the past 5 days, 7 days, and then the situation becomes, usually the situation becomes normally there, but there are other scenarios also. But the high level actions are this. If we go to the rack of problems, okay, so as I think Prabal said, rack of controls, who can do what. Okay, a small change can cause started task to fail. Okay, application to lose data set access, commands to be rejected. Maybe Mohan will say, my application was running very much fine from the past 1 years, but suddenly this has got abandoned. We have not done anything. We don't know what to do. Okay, there can be a change from the rack of side, from the rack of security team. Okay, which has changed some permissions. Maybe your application is not able to write the data, or maybe your application is not able to access some of the data because of the security permissions have been changed. So these issues are very, very scary, because Mohan will say to me, my application was running very much fine. My production job was running very much fine from the past 5 years. Nothing looks broken. System IPL is fine. If you do the IPL, system IPL is fine. Job submits at the same time within the SLA window, but suddenly the applications fail. And then if we check the logs after doing the initial investigations, then if we don't find anything in the application side or job side, then we will see, okay, maybe this can be an access issue, maybe access denied, these all things, right? So I will say one wrong rack of rule can impact dozens of application instantly, right? So there is also one more thing with respect to access. We have certificate related problems, right? So we use certifications for the connections like TLS SSL connections. We will not go about what are TLS SSL, but there are secure APIs, middleware communication, right? Many started task depends on the certificates to start successfully. If we have to communicate to the outer world, we need some certifications installed for that task also. So how certificate problem looks to us? If it expires, if it's deleted, if it's replaced incorrectly, certificates do get expires. Okay, after 3, 4, 5 years, it gets expired. It can be deleted manually also with probably a human error, we can say. Okay, so when this happen, started task will fail. Okay, secure connection suddenly will fail. Right, application report. The handshake failed. Handshake failed means communication testing. Okay, so this will not point complete error to the record at first. So if I say, if I see it, it looked like an application outage to us. But once we deep dive into this, we have to means install the certificates at that right away at that moment with the correct files we have. Okay, so this is what one RACF rule or one expired certificate or one wrong action on the security side can impact to the business. So let's go to the next. Yeah.
Hey, Saurabh, we can close it somewhere. This slide. I think,
Yeah,
and
we
then
can
we'll do
close.
one more, because there are people saying,
Okay,
can
fine.
we do it as a separate session? So we'll
Fine,
do it
fine.
as a separate session, like we can collect more topics that they want to hear, and then.
Right, right. So maybe next session will give us deep dive into the modernization on the mainframe side, particularly to the zOS system programming and all those things, and we will cover in the next slide, team. Any questions to us? If anyone has any questions, you can reach out to us. I am. We can share our email IDs to you, phone numbers to you. Yeah.
I can also stop the recording now, and then people, if they want to stay back, they can stay back and ask questions. We won't cover new topics, but if you just want to talk something, then
Sure.
And if Saurabh has time, and then Prabal has time.
We have Chantil.
No, we
Okay,
also
I'm going to stop the recording.
Yeah, sure.
This is a very good session. Thank you.
You're welcome.
Thank you. Thank you.